I'm Krishna Pomar. So I have around 16 years of software development experience. So where I have worked as a SRE DevOps engineer for 8 years, and then I've also spent my time in test automation. So today we will see about a use case that we have solved in Smarsh. So how did we achieve our SLAs, right? So what are the problems that we faced, and then what is the solution they have built, right? So in this session, we'll talk about the Smarsh introduction. So what's the product all about, and the overall high-level architecture, and then the SLAs that we have with the customers, then the problem statement, and one app that we have built for all of these solutions, right? And the internal scripts that we have built. So we will see all those scripts in detail and the conclusion. Right. So what is Smarsh? So Smarsh is basically a SaaS-based company. So providing a solution for the archival solutions as well as compliance data as well, right? For the highly regulatory industries. So we have 100 plus channels. So we support all the channels. Like we have around Teams, be it could be Skype or WhatsApp, any channel that we have now. So all these channels have been supported by Smarsh. So and then we have around 6,500 customers plus, and then it is increasing. So we have around all over the world we have the customers like JPMC, JP Morgan, BNY, and NatWest, right? So all of these customers use a server solution to store their archival data. And then what's the load that coming in, right? So we have around 3 billion plus messages coming in daily. So this could be a huge potential for us to maintain the data, and then it's not an easy thing to ingest this data. So we have many problems involved that we'll see in detail. Right, so that's a pretty quick introduction about Smarsh. And then I've just trimmed the architecture only for this session. I'm not dwelling deeper into the architectural details here. So whatever is session required, right? So I'm trying to cover only that. So to start off, we have the entry point. That's where the capture or vantage we call it as. So that's a gateway that we have done integration with the customer. So that's the data comes there. So as and when the data comes, it logs a message into Kafka, right? And then we have on the other side of the Kafka, so we have all these topologies that running on the Storm network, right? So be it could be ingestion service, be it could be discovery service or indexing service. So all these services are deployed as a topology. So basically these services will try to read the data, it parses the data, and then it stores the data, right? Yeah. So as and when it processes the data, it stores the metadata into the Mongo database, and then it also stores so what do we store in Mongo, right? So we basically store the received time, the start date, the number of attachments, the file size. So we use all this for the downstream applications. So all those data gets persisted into Mongo database, and then we store the document as such in the Elasticsearch. So it will be indexed and it will be stored in a Elasticsearch database, right? So we have the final state called archived. So what is the state, right? So as and when the services progresses to try to read the messages, right? So it will try to put a state. So let's say, for example, the document is queued, and then when it moves to the next stage, that is processing state. So it will be in progress. So like that, we have multiple stages in between, and the final state is called as archived. Right? So the moment the document is archived, so that will be exposed by service to the UI, and then that's what can be seen by the customer through the UI portal, right? And we have the respective teams working on all of the services. So be it could be capture. So capture team is responsible for all of this deploying, maintaining, or observability of all these services. So similarly, ingestion team takes care of the ingestion services, and the indexing team, and then exports and insights and conduct. Yeah, this is a pretty high-level architecture of Smarsh. Now let's see what is the SLA. So we agree with the customer saying that all the data that gets ingested within 90 days, so that should be archived, right? So when I say archived, that should be available in the UI for the customer. So and then we also have further time intervals where we expect the data to be archived. So what are those? So what the SLA says is, like any data that we receive within 1 to 7 days, so 90% of the data should be archived. And then any data that we receive 7 to 30 days, that should be 99.99%. And as and when it progresses 30 plus days, so you can see a precision of 9 getting added, right? So on the whole, within 90 days, so the whole data that we receive should be archived. So that's the SLA, right? Now, I mean, you can imagine 3 billion, on an average, we are getting 3 billion messages. And then imagine the load coming in, then the issues that we face. So what are the issues that we face, right? So the main thing is we are not able to meet our SLOs. So why we are not able to meet our SLOs? Because our supporting SLAs have not been met, right? So, and then we also have failures related to the data corruption. So when we try to read the data, so most of the scenarios we feel issues with the data corruption. Maybe the XML is not properly formed, right? And then the indexing. So when we try to persist the data in Elasticsearch, we have few indexing issues as well, right? And then the XML parsing. Sometimes even the XML, we are not able to parse it. It's a new thing altogether coming in by the customer. So we are trying to fix this. So we have a respective state also for that. So all the data corruption issues that you see here are marked as fatal issues, right? The system is trying to mark that as fatal and indicating that there is some problem in the system for those IDs. Similarly, for the indexing issues, it will be marked as stored, right? And then we have all the XML parsing issues marking as failed. So normally what we have seen, like majority of the cases, like 99% of the time, all the IDs will transition smoothly to archived state. But less than 1% of the IDs will encounter issues. Like I said, data corruption, indexing, or XML parsing, right? So when I say ID, so ID is a unique ID generated by the system for the communication within the employees, right? So any communication that happens between the employees, that will be marked as a unique ID and it will be sent to us. And that's how we track the ID. Right? And apart from these issues, we also have like a lot of manual toil. Like somebody from the SRE team should try to look into these failures. They have to identify the problem, and then they have to look into fixing that, right? So, and apart from that, we also need to do a cross collaboration with the engineering teams. So there are also problems with the ownership, right? So the teams will not be able to take up the failures. They'll be occupied with any of the other priorities that they have got. So these are the challenges that we had. And on top of it, we also need to be transparent to the customers. So when they are worried about these IDs, like which are not getting ingested, so they'll be questioning about this transparency, like what's happening for these IDs, right? So we are also responsible for these IDs. Now, what is that solution we have done? So I mean, we have built an app called Roadrunner. I mean, the names will be funny, but why we made it as just for a differentiation, and then we want to build a resilient application, right? So what is the app built? So you basically, this is tech stack that we have used. So Python Fast API, and then the Celery, and also Jinja 2 to render the HTML content, and the plain JavaScript. So we also use MongoDB to store the internal data, and then Redis as a queuing service we have used. So what is the app made up of? So there are many workflows or many scripts that is involved in the overall state of the application, but I want to focus only on these 4 scripts, right? So I'll dwell deeper into these scripts, individual scripts, and then we will see what this script does and then how it solves the problem. Right. And also this is a high-level overview of the Roadrunner app. So as I say, we also have the downstream applications. Like for example, we have the daily health checks that's been sent to the customers. So we are dependent on the system data, and then we need to provide some APIs for that. So this app exposes some APIs so that those data is read by the system, and then these emails are sent. And apart from that, we also use the billing data, right? So based on the storage data that we receive, we basically calculate the billing and send an email to the customer saying that this is what the bill that we have got for this particular month. So this API is being used. Sorry. So we are using Fast API to expose the APIs, and then the Jinja 2 for rendering the HTML content, right? Right. So, and sorry for the interruption. Right. So we are also using Redis, as I said, so as the queuing service. So whenever the SRE team logs into the app and then triggers any scripts, so this will be stored in the Redis, and then the respective services are being picked up by the Celery worker threads. So anybody has worked with Celery here? I mean, have you heard anything about Celery? Right. So Celery is a kind of queuing mechanism where it will help you in maintaining the worker threads. So it encapsulates all the logic in creating of the task or the threads, and then it will try to maintain the status of the threads, right? And then we have the respective scripts running on. So we will see what are those scripts. And then we have the databases. So like I said, we have the archive database. So this is a recon DB that I spoke about. So where we store all the data that we receive, right? So this is a product data that we store here, right? So RKDB is the one where we store the metadata. So what the recon scripts does is it will try to take a copy of the actual DB, and then so that we don't corrupt the actual database, and then we run all our recon scripts on the reconciliation database. So we also have something called beat worker. So what this beat worker will allow us is to run the scheduled jobs, right? So we can run the scripts, which can be triggered on a daily basis, or it can run on a every 4 hours or every 8 hours. We can configure that using a beat worker, which is inbuilt as part of the SLREday workflow. And then let's move on. So this is this daily state verification script. So what it does is, so it runs for every day. So what it does is it goes back in time. So let's say, for example, today is 14 September. So it goes back to 3 days back in time. So that is 11 September. So it takes the data that is ingested between 00 hours on that day till 23:59. So the whole data that it's been ingested into the system, it verifies all the states of the IDs, right? Like we said, we have multiple states involved, like queued, failed, fatal, and all. So it will try to pick up all the IDs which are in failed state, and then it imports the data to another collection called recon DB, right? And then it stores the data. So every day the script does this thing, and then it's a daily process. So why 3 days, right? So we are giving a cooling period or settling in period. So as and when the system, sometimes it takes some time to auto heal. So few IDs will not be immediately moved to archived. So it will take 1 or 2 days sometimes, right? So considering that cooling period, so we are trying to give this, and then we are running the script, which is for 3 days back in time, and get all the data, right? Let's move to the next script. So this is the next script that we have, so which is a periodic dynamic update script. So this will be executed on every 4 hours. So what this script does is basically try to refresh the data that we have in the recon DB, right? So now that we have taken a copy of the actual data, so sometimes within 4 hours, the states of the IDs would have changed. So to refresh the latest state, we are trying to get the data, right? And then it updates the IDs which are in the, it tries to remove the IDs which are in archived state. So that's the purpose of this script. And we are using pandas data frames here, right? So when we deal with multiple huge data, so we have issues with, parsing or, memory issues we had. So with the help of pandas, we were able to pandas data frame. So we were able to reduce the memory issues, and then the script became faster as well. And then this is the last script that we have in the workflow, so which is auto remediation script. So what this script does is, it runs for every 4 hours, right? And then it will try to pick up the failed states. For example, in this case, there's a stored data which is stored IDs which have been sent to the indexing API. So we have the indexing team expose this API, and then we need to run this ID with a particular API. So similarly, all the failed IDs, it needs to be called by an exports API, and then the fatal messages have been called by ingestion API. So we are basically trying to retry the mechanism, right? So by calling the respective APIs. Excuse me. Yeah, and this is another script that we have. This is a daily Jira creation script. So this is an actual script which creates the Jira. So the manual toil that we spoke about, right? So we need to inform the teams about the failures. So what are the IDs that we have, and why the IDs failed. So this script will try to create the Jira. It runs every day. It creates a Jira, right, with the attaching the IDs of the failed ones. So based on SLOs. So like we saw, we have SLOs for 1 to 7, 7 to 30. So similarly, it creates these SLOs. This creates a Jira by attaching the respective IDs along with the priority as well. The script will decide like what is the priority needs to be set. So the IDs which are being ingested within 1 to 7 days are not marked to final state. So that will be created as P2, and the IDs which are in other states like 7 to 30 or 7 to 30 to 60. So all that will be created as P3. And also we have syncat integration. So what is syncat? So as and when any Jira is created, so the syncat is the one, what it will do is it will try to create a Slack alert or Slack team, and then it will try to add all the team members that is involved as part of that incident. And then it will send a message saying that this is what the incident is created, and all the IDs will be attached in the particular sync. So now, the moment the sync is created, it will try to hook the respective teams, right? So now the teams are getting notified with all the failed IDs. So now they can easily go back and they can fix these IDs, right? So like this, it will try to inform the respective indexing team, the ingestion team, or the exports team. Yeah, we have come to the conclusion of this session. So with the system, now what we have done is with the Roadrunner, we are able to detect automatically any alerts that's been in the system. So where the IDs have not moved to final state. And then we are trying to avoid the potential SLA breaches, right? So apart from that, we also given this dashboard. So this will tell you the customer that how much percentage of the data has been archived, right? And if any unreconciled IDs are there, so what are those IDs? Yeah. So that's the end of the session. Any questions?
Thank you. My question is about measuring the impact of this tool that you've created. Do you have any data to track just how impactful this has been in terms of you not breaching SLAs? I know the assumption can be made that you have this now and therefore the effort put into creating it justifies the outcome, but I'm curious as to what the actual, the impact of this as it's been measured. What is the difference in SLA breaches and so forth since this?
Right. So the impact majorly would be before this app, so we used to manually create these incidents or inform the respective teams, right? The manual toil that we involved in all of this is being automated now. So the SRE team can focus on something else. So they can build the tools, whichever is necessary for other applications, right? Mm-hmm. So this is what we have done. And apart from that, we also set the monitoring dashboards for this, so that if any exception comes, so it will be thrown up in the dashboard. And then it will also send an email to the respective teams. Right? The overall, if you say that, that's the only thing that we have done, right? So we are trying to achieve the SLAs. Alongside, we are trying to remediate the manual remediation that we have.
Okay. No, I understand. On that level, I was just wondering if you had anything that you'd captured in terms of it's quite difficult sometimes to do something like this, but capture the amount of time back that you've gained from this tool. 'Cause I'm just thinking implementing something like this will have an upfront cost, and if you're thinking about doing something like this in your organization. So I was just, do you have any data, or is it you mean just we feel as a team that we have more time back and so forth?
Yeah, the time we spent, it's we have spent around 3 months of effort. So we got together, the SRE team got together, we brainstormed on these events, and then we developed in-house, right? So this is what we have spent the time here.
So what's the data, in the platform where this has been sort of implemented, what type of data are you trying to capture? What type of fail data? I assume this is, implementing a data platform where you get, as you mentioned before, mm-hmm. you get, bad data and so on. So do you have a bit of of a live example of what this has been used for? What type of use, have you implemented this for?
Right. So, as I said, the SMART is a regulatory, we basically store the data that's been regulatory used by the companies, right? For example, we have JPMC. So all the messages that's been communicated within the bank or the FinServe companies. So the employees that they do communication, so that will be sent to us. So this is for the supervision purposes and then the compliance purposes.